Greetings everyone. Welcome to a new episode of mrbioinformatix. We all love nature, the trees, the flowers, and the way it makes us feel calm and happy. For a long time, people have been amazed by the patterns and numbers we see in nature, art, and buildings. Mr. Bioinformatics, how are patterns in nature connected to numbers? My dear viewer, these numbers are part of something special called golden ratio. It's a number that shows up everywhere from the petals of flowers to famous paintings. The golden ratio is beautiful mystery that we can find it all around us. It's also known as phi, which is about 1.618, and sometimes it's called the divine proportion because it looks so beautiful and mysterious in nature. But how did we find this number? Around 500 BC, Greek sculptor Phidias used the golden ratio in designing the Parthenon, a temple dedicated to Athena, the goddess of wisdom and courage. And around 300 BC, in ancient Greece, the mathematician Euclid, he described what we now call the golden ratio. In his famous book, Elements, he referred to it as a dividing line in the extreme and mean ratio, and explained it in terms of geometry, focusing on shapes and sizes. Specifically, Euclid defined it as a ratio between two parts of a line. Imagine you have a line. You split it into two sections. The golden ratio occurs when the whole line relates to the larger part in the same way the larger part relates to the smaller part. Mr. Bioinformatics, I don't understand anything. Please make it easier to understand. Look, my dear, it's like when your brother splits a sandwich between you and him, and somehow he ends up with the bigger piece, but he still thinks it's perfectly balanced, even though you are pretty sure he's taken the advantage. The longer part is it to the whole line, and the longer part to the shorter part. Euclid's work laid the foundation for the term golden ratio, and it uses it in geometry, even linking it to the construction of a pentagram. In ancient Greece, the pentagram was a special symbol for health, balanced, and perfect math. This creates a special balance, and it shows up naturally in nature and art. In 1202, the Italian mathematician Leonardo da Vinci, he introduced Fibonacci sequence in his book, Fibonacci, which played an important role in introducing Hindu-Arabic numerals to Europe. This sequence, which starts with 0, 1, 1, 2, 3, 5, 8, 13, 21, and continuous, closely approximates the golden ratio as the numbers grow larger. For example, 21 divided by 13 gives you approximately 1.615, and 13 divided by 8 gives you approximately 1.625. Fibonacci learned this sequence while studying in North Africa, where Indian mathematicians had already explored it centuries earlier. Have you ever wondered why we like the art of Leonardo da Vinci? In the 15th century, the famous Italian artists and scientists, they studied the golden ratio, especially in his drawing Vitruvian Man. Da Vinci used this ratio to find the perfect proportion of the human body, aiming to create balanced and beautiful figures. His use of the golden ratio in art has influenced architecture, engineering, and design for many years. But the golden ratio story doesn't stop there. In the 19th century, mathematicians and scientists took a closer look at the ratio and found something fascinating. It's closely connected to the Fibonacci sequence. As the numbers in the sequence grow, the ratios between the consecutive numbers gets closer and closer to 1.618, which is the golden ratio. The golden ratio does not just appear in art and math. It's also show up in nature. But how? From the spiral of snail's shell to the petals of a flower, the golden ratio can be seen in the way leaves are arranged on a stem, how trees branch out, and even in the growth patterns of hurricanes. It's as if nature has a built-in preference for this ratio. But why? It's not just about beauty, it's about efficiency. In plants, for example, the arrangement of leaves and petals in the golden ratio ensure that each part gets the maximum exposure to sunlight without blocking of others. This helps the plant gather more energy and grow more effectively. Similarly, the spiral pattern of a snail's shell follows this ratio, allowing it to pack more structure into less space. The golden ratio is not just visually pleasing, it gives nature the tools to grow in most efficient way possible, making the best use of the resources available. In the 20th century, scientists and artists started to see that golden ratio is not just a strange math idea, but something important in how the universe works. For example, Swiss-French architect Le Corbusier used it to design buildings that feel balanced and calm, while Spanish artist Salvador Dali used this ratio in his painting The Sacrament of the Last Supper. As people admired this ratio, one big question remained. How does the golden ratio affect what we found beautiful? Why does it seem so pleasing to the eye? The answer is all about the harmony. The golden ratio helps create balance and order, which our brains naturally find it pleasing. It's not just about numbers, it's about symmetry, balance, and proportions that feel right to us. Okay, Mr. Bioinformatics, we understood the symmetry, but what about balance? Have you ever listened to a piece of music and felt everything was perfectly in place? As if the music was meant to sound just that way? What if I told you that some composers use special formulas to make the music feel balanced and beautiful? That formula called golden ratio. One composer who used the golden ratio was Bela Bartok, a Hungarian composer. In early 1900, he carefully arranged music so that the important moments like changes in speed or mood happen at a point that follows that golden ratio. This made the music feel balanced and smooth, which our ears find pleasing. Another composer, Ludwig van Beethoven, a German composer from 1770 to 1827, seemed to use the golden ratio in his music. While it's not certain that he did this on purpose, many music experts say that his symphonies have changed at points that match the golden ratio. Do you think it's by coincidence? But how they can use the golden ratio in music? Imagine a melody that lasts for 8 bars. In music, a bar is simply a group of beats. Think of it like a box that holds a certain number of beats. In many pieces of music, each bar has 4 beats. This is called a 4/4 time signature, which is one of the most common time signatures. So when we say 8 bars, we mean that there are 8 groups of 4 beats, which add up to 32 beats in total. Now, according to the golden ratio, a key moment in the music, like a change in the rhythm or melody, should happen around 5th bar. Why the 5th bar? Well, if you divide the 8 bars into 2 parts, 5 bars and 3 bars, the ratio of the 5 to 3 is very close to the golden ratio, which is 1.618. This creates a natural balance in the music that our ears find pleasing and comfortable. Scientists have also studied the golden ratio in the human body. For example, from distance between your eyes to length of your fingers, the proportions of your body often approximate the golden ratio. Many people believe that the closer someone's body proportions are to this ratio, the more pleasingly they appear. Someone might ask, Mr. Bioinformatics, how does something so mathematical relate so deeply to our sense of beauty and harmony? Well, it turns out that golden ratio does not just appear in nature and art, it may even influence how we see beauty in people and objects. In 2011, Dr. Gert, a German physicist and biologist, he published his book Beauty and the Beast: The Golden Ratio in Art, Architecture and Nature. In this book, Dr. Hausler explored how the golden ratio influences human perception of beauty, recommending that this proportion found in art, architecture, and nature plays a key role in how we perceive balance and harmony. He suggested that the golden ratio is psychologically ingrained in our perception of what is beautiful. In fact, Many cosmetic brands and fashion industries take the golden ratio into account when designing models and products. For example, some modeling agencies look for facial features that align with the golden ratio, believing that faces that follows this ratio are perceived as more attractive. Some brands even use it in their logo designs, like Apple, Twitter, and Google, ensuring that the shapes feel balanced and visually pleasing. So next time you see a flower, hear a song, or even gaze at a logo, remember that the golden ratio might be behind it, creating that perfect balance. Let me know in the comments if you'd like an episode about other mathematical wonders. And here we've reached the end of our episode. Thanks for watching, see you next time.